this video, we're going to go over composition functions. So they might sound a little bit confusing, especially if you've never seen them before, but they are basically functions of a different function. Sounds intimidating, but it's very, very simple. So all of you have seen different types of functions. Let's consider the following for the sake of example. Let's say 2x squared minus 2x plus 3, right? So in this case, we have our variable x, and when we plug it in, we are going to get a specific output. But in composition functions, our variable becomes another function. So g of x is going to have some value, right? It's going to be a line, it's going to be a polynomial. All we have to do to find the composition function that's labeled as f of g of x is to plug in g of x, whatever it is, into every single x in our f of x. So let me show you an example. Let's say that f of x remains the same, but our g of x will be equal to, let's say, 4x. Just to keep it simple, at least for now. Then f of g of x will be our function f of x, but instead of x's, we're going to have the value of g of x, which is 4x. So that's 2 parentheses 4x squared minus 2 times 4x. And then we have just plus 3 because there is no variable associated with that. So all we have to do to find this composition function is simplify it. FOIL it out, take the square, or whatever you got to do. So we're going to have 2 times 16x squared minus 2 times 4x is 8x, and then plus 3. So lastly, we just have to multiply 2 by 16. That's 32x squared minus 8x plus 3. And that's how you do it. Okay, in the next example, let's do something slightly more difficult. In this case, we had a simple linear function as our g of x. In this case, let's actually reverse it a little bit. Let's say that I want you to find g of f of x. Well, that should be fairly simple. So we have our function g, right, which is 4x, but instead of x, we are going to plug in our f of x, which is 2x squared minus 2x plus 3. And all we have to do is multiply every single term of f of x by 4. So it's 8x squared minus 8x plus 12. Beautiful. Now on the next one, let's consider something slightly more difficult. Let's say that our f of x is 2x squared plus 5x plus 1, and our g of x is equal to x squared minus 5. So once again, in order to find any composition function, you basically plug in the second function into the first function for every single x. So f of g of x is our f of x, but instead of x's, we're going to put the value of g of x. So it's x squared minus 5, all of that squared, plus 5 times x squared minus 5 and plus 1. Okay, so now you have to take a perfect square. That's the only thing that's more difficult about this example than the previous example. So we have 2 times x to the 4th minus 2 times 5 times x squared, and then plus 25. I specifically wanted to write it out because I'm assuming some people might not be comfortable with perfect square formulas from the get-go. And then we have plus 5x minus 25 plus 1. So let's finish it up. We have 2 times x to the 4th minus 10x squared plus 25 plus 5x minus 25 plus 1. Seems like I forgot the parentheses somewhere right here. And now all we have to do is multiply 2 by every single term inside the parentheses. So we're going to have 2x to the 4th minus 20x squared plus 50 plus 5x minus 25 plus 1. Run out of space here, but let's finish it off in the new line. So that's basically it when it comes to variables, but we can simplify these numbers. So we're going to have 2x to the 4th minus 20x squared plus 5x, and then 50 minus 24 is positive 26. And that's it. That's how you calculate composition functions. They're fairly simple, shouldn't be too confused. You can probably expect more difficult examples with a square root or something to the 3rd power. But if you are following these rules of basically replacing every single x with the function that you're going to plug in, you're going to be absolutely fine.